All right, it is 8 o'clock, so I would like to welcome everyone to this session and introduce our speaker, Kerri Spooner, who will be talking about providing contextual learning through mathematical modeling. I turn it over to you, Kerri.
Thank you. Welcome, everybody. Thank you for coming to this session. I can see that I have my colleague from Australia is also talking at the same time, and I acknowledge that it's probably quite late for you guys on a Friday night. So here we go. I'm sitting here in New Zealand, and it's 2 o'clock on a very, very hot summer's day, and I've just turned off the fan. Anyway, let's get started. Now, just to check, Anna, can you see a green screen that has the title of the talk and my name on it?
Yes,
Good, so we're good to go. Okay, wonderful, thank you. Okay, so this afternoon I'm going to be talking about possible ways of using mathematical modelling to provide contextual experiences of differential equations. And here we go. So the background for this, here we go. So the background of what I'm going to share with you today comes from a study that I carried out in New Zealand that involves 3 different case studies of mathematical modelling courses. So each case study had a mathematical modelling course, the lecturer participant, and voluntary student participants. And each course had a different approach to teaching modelling, used a different type of modelling activity, and what was common across all courses was that all the modelling activities occurred in groups. So just before I start sharing with you the details of the activities, is just to show you a little bit of a background of all of the courses. So we can see here for course 1, they use an open-ended modelling activity that took place over a full day, over a 7-hour day. Course 2 used case studies of already developed models for students to start to get to know the modelling process and also to modify the case study. And course 3 used fictional popular culture for students to model the activities. Now, each of the courses had a different focus on the modelling cycle, and also there was different levels of ownership for students around the responsibility for decision making through the modelling process. So for the open-ended activity, it was just that, very open-ended questions. All the decisions, including what foundation model to use, was done by the students. The lecturer, though, had a very explicit focus on the modelling cycle throughout the course, and I'll explain a little bit more about that in a minute. For course 2, the focus on the modelling cycle was there. They started off with the first lecture being all about modelling, but then the course tended to be a lot more focused on some of those traditional differentiation tools around modelling. And when it came to the case study, it was very, the modelling cycle wasn't referred to as such. It was basically left a lot of implicit learning by the students, until, of course, they came to the stage where they got a chance to modify the model of the case study. And for course 3, again, had a very similar approach to course 1, very explicit exposure to the modelling cycle throughout the course. There was a difference, though, between course 1 in that the lecturer gave the students the foundation model to use in order to develop their models. So here we go. Let me start sharing some of these activities with you. So what I'm going to do for each of the courses is share a little bit of information about the background of the course, share with you the main modelling activity used, and some examples of the students' use of differential equations in the activities. So we'll start off with course 1, open-ended modelling activities. So as I have said before, is that what happened was the students all took, these modelling activities took place in student groups. The students all had to turn up to university on the day of the nominated project day. And then the open-ended question was emailed through to the students at 9 o'clock. And then they had 7 hours to work through developing a model for the question and then submit their report. And some examples of some of the open-ended problems that were being used, like this picture on the left, was if a CubeSat satellite collided with the moon, How big would the crater be? How high can you jump from a building without causing injury? And this photo here over on the left, you might recognize it from up in the air, is how many balloons would you need to be able to lift a house off the ground? So really quickly, let's have a little look at what was happening sort of behind the scenes within the course, which meant that that modelling was going to be possible for these students. So in course 1, during the lectures and tutorials, the lecturer was focused on developing the techniques for modelling. Actually, I should probably say this course was a course for engineering mathematics students for a little bit more of the background. And when I'm talking about developing techniques for modelling, that means that they were focused both on the mathematical modelling skills as well as knowledge about the modelling process. So around the mathematical modelling, the mathematical techniques, just for a bit of background, they were teaching dimensional analysis, optimization, rates of change, curve fitting, as well as presenting standard models, and as well as lots and lots of different, and all those differentiation techniques, including analytical, numerical, and integration techniques. Now, as far as acquiring the knowledge of the modelling process, as I've already said, this lecture had a huge focus on making sure that they were explicitly exposing the students to the modelling cycle. The first week was dedicated to the modelling process, and then throughout the course they were frequently alluding to the modelling process as they were presenting models and having the modelling the modelling cycle running alongside and making connections between the model that they were showing and what particular different stages of the modelling process that they were representing at that point in time. They also shared with the students a lot of heuristic strategies for modelling, and by that I'm meaning things like draw a diagram, keep it simple, remember, keep it simple, and make a plan. Now, before they undertook the modelling project day, the lecturer held a pre-modelling day tutorial, and what he did, the lecturer actually selected the groups for this particular course, and he selected them so that there would be a range of abilities, the best he could to get a range of mathematical abilities within one group. And then on the pre-modelling day tutorial, it was the first time they were put in the groups that they would be working together with for the project day. And in that tutorial, they were looking at getting to know each other, what their strengths and weaknesses were, some specific activities around effective group work skills for mathematical modelling. And the other key thing that happened in that tutorial was an exposure also to what the criteria was going to be for assessing their open-ended modelling project. And with the assessment, a little bit different to a traditional way we would traditionally assess a piece of mathematics. Yes, there were some marks for the solution, but there was a lot less focus on the marks for the solution and more focus on marks for going through process. And even in the instruction sheet in the assessment criteria, and also in the instruction sheet they received on the day, the modelling process was given to the students, and so that there were really clear reference to them about making sure that when they wrote their report up, they were also writing about their process and writing about the different stages that they went through with the modelling cycle. And what I also noticed when I was going through the data too was that a lot of the students were drawing on some of the resources that the lecturer had set up beforehand. And it was really interesting because what they were drawing on were the worked answers for the assignments, both their own and past cohorts, and also past worked exam problems, because the assignments and the exam problems that this lecturer had in the assessment part of the course were focused on the modelling cycle, and were also really the bits of the process were detailed along with the workings within these solutions. So let's have a quick look at some of the mathematics for this particular open-ended problem. How high can you jump from a building without causing injury? So there is a piece of the student's work, and even though what I'm showing you, the students did actually abandon and rework their model and abandoned this particular approach, I thought I would share it just as an example. And what we have here is we have the students drawing on Newton's second law and the laws for kinetic and potential energy. We have them formulating their first equation to represent the downwards and upwards force generated on the bones from the jump as being equal in order for the bone to break. And then as they carried on working through it, when they realized that time would be needed in order for them to find out the height of the fall, they decided to abandon it and discard it. But even in the whole process of them working through this and then realizing, oh, hold on a sec, where we've got to is a little bit of a sticking point for us tomorrow, and then changing their approach, to me was a really good example of some of those behaviors that sometimes we don't value highly enough in our mathematics classroom, about that exploration and going down blind alleyways, because it is still useful to explore something, decide maybe you don't want to continue with it, and then turn around and come back again and turn around and rejig things and take a different approach. Now for course 2, they used the case studies, and the case studies that they used came out of the Barnes and Philly, and let me see, hopefully I said this right, Philford 2015 Modelling with Case Studies book. And what happened here was the students were given these 3 different case studies. As you can see, one was about how hot the air gets in an attic. Another one was about controlling the possum population, and another one was about controlling the prickly pear population. So what we had happening in this, actually we'll go back again, was that the students, actually here, I'm going to explain that in a minute. So let's just start up first of all what was happening during lectures and tutorials. Again, focusing on the modelling tools and mathematical tools. And there we go, those ones again, pretty standard ones. The acquiring knowledge for the process, acquiring the knowledge of the process of mathematical modelling. Now, this lecture did start off with the first lecture being about modelling, and then the focus was then moved to being quite sort of traditional mathematical modelling type skills. And then it was through the case study, and her objective was that by students actually studying the case study, they would get to know the model, they would get to know how a model is put together, and then have a go at modifying the case study would give them what she perceived to be a really good introduction to the modelling process with it, but without making things too difficult for them. The students were also required to give presentations of the work that they were doing with the case studies. And during the presentations, because they had to present the material, it really forced the students to engage with the material in the case study. It gave the lecturer an opportunity to what I have some teachable moments, that when students were presenting, that she could then use what the students were presenting either to really highlight some skills or some process that the students had role modeled to the rest of the class, and use the students' work as a teaching point, and then to also very gently, and I can imagine very sensitively, use some of the students' works to maybe resolve some misconceptions. And the presentations also meant that students got time to actually practice asking questions and receiving questions from the audience. So there we go. So basically what happened, students were in one lecture, they were presented 3 different case studies, and they had to rank them in order of preference that they would like to work on, and then the lecturer formed the modelling groups based on the common interest for a particular case study. Then they had to do not just 1 presentation, but 3 presentations. So their first presentation was around just presenting the background of the case study, the model that the case study was looking at, and explaining some of those terms of the model. Second presentation was then around presenting and working through the mathematics of the model. And the third presentation was about identifying the limitations of the model, choosing a limitation, making a modification to the model, and then presenting the new mathematical workings for that new model and discussing its implications. And the case study and the role of the case study was that it was there to provide internal guidance for the students. And then, as I have said, that the lecturer was there at the presentations to then be able to provide steps forward into particular areas for them to follow up and continue working on with your engagement with the model for the following presentation. Okay, so here we go. What I'm going to do now is I'm going to share with you some of the students' work on one of the case studies, so you can see what the students actually did. So this one is about the prickly pear. So this is their first presentation. The first presentation was around the background, and as you can see here, they're talking about when the prickly pear was introduced. They'd gone and found out when the prickly pear was introduced into Australia, how it got out of control, how there was a moth that was introduced to control this prickly pear population. Then they presented the model to the audience, and as you can see, it was all about just explaining what these terms in the model were. Like, we're looking at the rate of change of the pear population in respect to time, and talking about the different units for each of the different variables and parameters of the model. And the second presentation is about the mathematics of the model. And so here they go, start up again, a recap of the model. Then they start looking at the fixed points, so they can start investigating the behaviors around the fixed point. You can see that they get this really nasty equation down here. So they have a lot of fun trying to explore the mathematics about how to make some headway with that. So they start, here we are, opportunity now to start drawing some different solutions and having a look at the phase planes. Looking at now, using your Jacobian matrix to have a look at your stability of these fixed points, and then playing around there, and then drawing yourself up through having a look at a plot of the two populations of obviously different initial conditions over time. Here we go. And then if we have the third presentation, which is now about them presenting the limitations of the model and suggesting the modification and working it through. So for this particular case study, the students found out after doing a bit of research that they settled on, really, they all went off and researched all different areas of what could be the possible limitations, came back into their groups, shared it, and then decided on addressing the fact that the moth, obviously depending on the different temperature, will have different birth rates depending on whether it was summer or winter, and they decided that was missing from the model and it would be a good modification. And they even found a nice research paper that talked on it, which sort of helped put them on the right direction. And so what they did is they generated a temperature function here, which they inserted in the model, and then defined their temperature function down through like this, and then started working through it. And as you can see now, compared to the first one, instead of having the two populations coming and meet, we can now start seeing the seasonal fluctuation. So there we go. But what was really powerful, I thought, about the case studies model was actually the presentations and the way the students got to see what other students were doing. And the comments I was getting in the student interviews were things like that they were like, oh, wow, that's a different way I can approach mine. So they were getting other ideas from their peers. And then they were also going, oh, good, I was approaching it a similar way too. And getting affirmation. So I found that was, I think, probably really the highlight, when I reckon, as far from a learning perspective, was for me, was about that presentation, so that we could have peer-to-peer learning. Then we've come to course 3, and I can see, Anna, that I've got just over 4 minutes to go. And now course 3 used fictional popular fiction. And they all had a zombie movie theme. I think you've got I Am Legend as a book based around zombies. Night of the Living Dead is a movie, and I'm pretty sure Brain Dead is as well too. So again, now the setup around the modelling for this, there was, as well as doing all the different topics, and I'll share those with you in a minute, there was specific teaching of the SIR model, because all of the zombie models were based on a zombie infecting a human and them turning into a zombie, and then infecting another human, but of course they all had their slightly different scenarios about how this would work. So the first thing the lecturer did was really focus on both the lecture and tutorial on the SRI model, how to manipulate it, how to make modifications of it, and how to explore its behavior. And so that the students were already prepared, they already knew quite a lot about the foundation model they were going to use. And then around acquiring the knowledge of the modelling process, the lecturer was similar to course one's lecturer in that he focused on the modelling cycle for the first week, and he used that first week to develop simple models, role modelling, developing simple models for the students, but using mathematics that they would have done before. And then by giving them also an experience of modelling through creating these models of fictional situations. Now, the fictional situations seem to be really good at taking the pressure off the students about feeling that they had to create a right or wrong answer. Because we were dealing in a fictional world, what I observed was it actually gave these students a lot more freedom to explore and try things out without the fear of something not being right. And again, yeah, I've just already talked about that. And the topics, just for background information that were taught in this paper, I'll just leave you to have just a quick look at those. Okay, so again, each of the papers had slightly different focus, as you can see. And the way the groups were formed in this particular paper, the lecturer had a slightly different way. He had quite a big cohort. As students came into the lecture theatre, he had different brands of sweets, and he gave them all a sweet, and then he grouped everybody with, say, brand A sweet as one group, everyone with brand B, another group, brand C, and then they were all assigned different zombie scenarios to work on. And just like in course 2, the students, once they developed their zombie model, also then presented it to the cohort. And again, we saw that the similar benefits that I've just shared with you about sharing your workings with your peers. So let's have a quick look. We're not going to, I'm here. So this was the scenario for Night of the Living Dead. It says a radioactive leak at a nearby military base leads to dead zombies becoming reanimated as zombies. The zombies attack and kill humans and can only stop by decapitation or being burnt. So now I didn't collect anything about the mathematics from the students here for this particular case study, but I did do interviews, and what came through in the interviews was common for all the student groups is where they were taking the SI model and they were changing it. Like we had Hazel saying, we had to determine what the important factors for our situation was and incorporate them into the model. We had Luke, 2 other students, saying, identified the variables and then assigning them to susceptible, infected, or recovered. Then we had the same students go on to say how they used their modified models to determine the numbers of susceptible, infected, and dead, and remove people, and how removed people actually changed over time. And then we have Luke coming on and saying, like, once we'd assigned the variables to the SI model, we had to come up with another variable for the people that had been bitten, but weren't infected or didn't die, but they came back as a zombie. So you can see the situation allowed them to go through the process of developing a model or then modifying it. We saw a lot of enjoyment. I suppose we got Hannah saying we got to apply modeling. I wouldn't say a real situation, but a situation, and actually having a go at trying to model something. It made me feel smart. Ours was insanely complicated because we tried to incorporate all the variables, but we did all right. Here we go. So I'll just move. Yeah, and again, we've got the comments about the benefits of those presentations, which I've already alluded to. Now I'll just finish on this, Anna. This is my last. It'll take me about 30 seconds. And I just want to share with you the 2 common insights across the lecture practices for all 3 courses. So basically, I saw that all of the lecturers designed and delivered their instructions such that it included opportunities for lecturers to role model mathematical modelling behaviours. Not just mathematical modelling like technical skills, but those actual behaviours. They also provided students with the resources to utilize, and they also promoted independence in modeling for the students. And I was seeing like all lecturers created opportunities for students to work independently, while also promoting independence as a key modeling behavior for the students to develop. And that to me was quite significant about that, actually regarding working independently. Obviously not independently, it was like working in a group to mimic the actual behaviors that we probably do particularly in an industry-based modeling team, that you work in a team, but you're independent of an authority figure that is going to be sitting there and directing you and telling you what to do. So thank you so much for your time. That is me done. And hopefully I didn't talk too fast. I'm a little bit prone to that. But anyway, I'll stop sharing now. And if there's time for any comments or questions, I welcome them.
Thank you so much for the presentation. There is a couple of minutes for questions. I have to get going because I need to moderate another session, but this room can stay open as long as you're here and as long as people are willing to ask more questions. So thank you again so much for the presentation.
Yeah, I have to get going as well. Or another one, but I do want to say, how many faculty were involved in this?
It was across 3 different universities in New Zealand, so it wasn't the same. So we had one from one university where the course was within the the mathematics department. The other university, it was from within the engineering department, and the other university was delivered by the maths department, but it was used as a service paper for a lot of geography papers, as well as computer science and as well as mathematics. In fact, they had a huge branch of geography students. Yeah.
The reason I'm asking is, did you have trouble getting faculty to buy into projects and modeling and all of these approaches?
Because I was coming in from a research perspective, these things were already happening in the courses. So I was interested in looking what was happening. So I think my biggest challenge now is about how we take some of their lessons and be able to incorporate them into some of the traditional courses that we've got. It's going to be the biggest challenge, which I think is what you're alluding to.
Yeah. Okay. Well, it's exciting times. I thank you. I have to leave. Take care, and everybody stay on.
Right.